In question 7a, we have to prove the identity 1 minus 2 sine squared upon 1 minus sine squared as 1 minus tan squared. Now, in this identity, we can see that we have to get rid of the denominator and convert it to a form so that converts to tan squared, which means we'll be needing to convert sine squared upon cos squared to a tan squared. Now, the identity is sine squared plus cos squared equals to 1. And we can also write cos squared is equals to 1 minus sine squared. In the numerator, in place of 1, we can write sine squared plus cos squared minus 2 sine squared. And the denominator, we can replace the 1 minus sine squared with cos squared. So sine minus 2 sine will become minus sine squared. So the numerator will be cos squared minus sine squared upon cos squared. Breaking up the denominator and writing it individually with the numerators. So this will become cos squared upon cos squared minus sine squared upon cos squared. So cos squared and cos squared will become 1, and sine squared upon cos squared is tan. So this will become 1 minus tan squared theta. In part B, we have to solve the equation of 1 minus 2 sine squared upon 1 minus sine squared equals to 2 tan power 4. Now we prove the identity that 1 minus sine upon 1 minus 2 sine squared upon 1 minus sine squared is 1 minus tan squared. So we can write 1 minus tan squared over here is equals to 2 tan to the power 4. So rearranging this will become 2 tan 4 plus tan squared minus 1 equals to 0. To simplify this, we can write this equation as, let's say we can use a substitution, x equals to tan squared. So x squared will be equals to tan to the power 4. Simplifying this, we'll get 2x squared plus x minus 1 equals to 0. Factorizing this will become 2x squared plus 2x minus x minus 1 equals to 0. Taking 2x common, this will become x plus 1. Taking 1 common, this will also become x plus 1 equals to 0. Simplifying, this will be 2x minus 1 and x plus 1 equals to 0. So x will be equals to 1 upon 2 and x will be equals to negative 1. Now the substitution was x is equals to tan squared. So when we use x is equals to tan squared theta, so tan theta will be equals to the square root of x. Now as we cannot take a square root of a negative number, so which means that this value will not be taken. Now taking tan theta is equals to square root of 1 upon 2. So theta will be equals to tan inverse of square root of 1 upon 2. So writing it as tan inverse of square root of 1 upon 2. In the calculator, we'll get the basic angle as 35.3 degrees. Now we know that tan is positive in the first and the third quadrants. So we'll make the 4 quadrants. We know that tan is positive in the first quadrant and tan is positive in the third quadrant. So the first value of tan will be 35.3. However, we have to look at the range, which is 0 to 180. Now, so this will be beyond the range, so we will not be taking this angle. However, the square root shows that we can also take the values of tan in the negative quadrants. So we'll also make 35.3 in the negative quadrant, as square root means both positive and negative values are considered. So the second value will be 180 minus 35.3. So one value of theta will be 35.3. And the second value will be 180 minus 35.3. So the final answer will be 35.3 degrees and 144.7 degrees.